How would you like an electronically steerable high-power K-band transmission antenna for your SATCOM research project? If the answer is yes, then let me show you how to construct a 78 dBn URP transmission ESA using TMYTEK BBox One and 4-channel solid-state power amplifier modules. Why is TMYTEK aiming to provide high-power microwave ESA solutions? Apart from 5G mmWave band, satellite communication is another application field with huge potential. SpaceX reduced the cost of launching satellites. It made LEO SATCOM viable and attractive, which is why so many tech giants are entering this market, including Starlink, Amazon, and Microsoft. The LEO worldwide market is estimated to grow at a CAGR of 19.1% from 2020 to 2025. The LEO satellite orbit velocity can reach speeds as high as 25,000 km per hour. So, beam steering latency and multi-beam capability will be crucial. Traditional dish antennas with servo motors will have a hard time tracking LEO satellites and negotiating handovers. ESA technology for in-flight communications and ground terminals is key to LEO's penetration rate. We provide Ku-band, Ka-band ESA solutions for various SATCOM ground stations, and we are ready for field trials by Q4 2022. TMYTEK welcomes any inquiries for SATCOM ESA total solution. However, if you are performing microwave or SATCOM research and need a testbed solution, we have the perfect one for you. We have created prototype electronically steered high-power K-band transmission antenna, and it can achieve up to 78 dBn URP. The solution was created in about 4 weeks and at an affordable cost. In the next 5 minutes, we will show you how the antenna was created with 13 TMYTEK BBox Ones and 48 pieces of 4-channel SSPA modules. The first task is to calculate the link budget. To achieve 78 dBn URP target, we have 2 choices. We can build an ESA with around 256 elements. Each channel has its OP1 dB around 32 dBn. To achieve output power, we put a 3-watt high-efficiency gallium arsenide power amplifier between the phase shifter and the patch antenna. With this design and calculation, we can achieve a 192-element transmission phased array. The simulated ERP is larger than 78 dBn. Since we are prototyping for a testbed, considering the availability of components, budget, and time, the following option may be more suitable. We can build an ESA composed of 2,000 elements, each channel with 12 dBn OP1 dB output power. But this involves designing a new K-band ESA with over 500 beamformer ICs. We will show you how fast we can deliver the prototype with TMYTEK's products. We designed a tile-based wideband 2x2 LTCC antenna covering the 26.5 GHz to 29.5 GHz range. LTCC stands for Low Temperature Coal-Fired Ceramics, and it is a durable, high-performance, high-decay, low-DF material suitable for microwave antenna substrate or carrier boards. By grouping all 48 2x2 LTCC antenna modules with a single 12 by 9 cm CNC alumni grounded plate, we have a 16 by 12 192 element phased array antenna. Its half-power beam width is 6 degrees, and the beam steering range is 22.5 degrees in 4 directions. This modular antenna design gives you the flexibility to scale to any array size and offers ease of maintenance. Also, we need to boost output power of each channel to 32 dBm. Our solution is composed of modularized SSPA. We found a proper 3-stage 3-watt gallium arsenide pseudomorphic HEMT SSPA MIMIC IC, covering 26.5 GHz to 31.5 GHz range, with good power efficiency. Its P1 dB is 32 dBm and provides a 23 dB gain. And we made a 4-channel SSPA module design for easy assembly. And it fits in most if not all cooling systems. Though it is already a very high power efficient SSPA, it still consumes up to 12 watts per IC. Then we look at DC power supply board. It is designed to supply the 4-channel SSPA module. It is also a modularized design. It provides one 12-volt power rail for one 4-channel SSPA module with a micro D-sub connector. Its double-sided design allows it to support 2 SSPA modules. Okay, after above components are prepared, we put together the antenna, PA modules, and BBox Ones to build this Ka-band high-power transmission ESA. The liquid cooling system is designed to keep all 48 SSPA modules as cool as possible. SSPA performance is highly related to its junction temperature. The challenge is to keep hotspot of each SSPA under 80 degrees Celsius in lab conditions. Keeping all 192 SSPA ICs at a uniform temperature is another big challenge. If the temperature gap is bigger than 10 degrees Celsius, it will be very difficult to compensate for the output power while keeping a high adjustable gain attenuation range. The 16 water pipes are made of CNC 6061 alumni alloy. Each one is attached to 3 SSPA modules with thermal interface materials. The water intake and output paths are interlaced to keep the temperature gap as low as possible. Let's look at the final test result. The SSPA hotspot is kept under 60 degrees Celsius, and the temperature gap is smaller than 5 degrees Celsius. We use TMYTEK BBox One as adjustable attenuators and phase shifters. To fully utilize 13 BBox One devices, we designed software to virtualize 13 BBox Ones into one 192-channel ESA. We can virtualize any number of TMYTEK BBox devices into multi-layer, large-scale phase shifters, and attenuator arrays of any size. For example, 17 BBox One to form one 16 by 16 256-channel Ka-band ESA prototype, and adjustable using the in-house developed 3D GUI. You can intuitively switch the beams or compose any beam you like. We tested it in an anechoic microwave chamber to verify its performance, including ERP, array antenna gain, and beam steering capability. We measured the patterns of all different beams in 4 directions, and they matched the simulation results. Our solution is very fast for prototyping. Assembly can be done with test up and running within 4 weeks. The design is very flexible. Any size, 8 by 8, 16 by 8, 16 by 16, or 32 by 32 can be realized. And it is a very comprehensive and completed software integrated solution. It is a good choice for academic and research projects. If you're looking for a KU-band, K-band, K-band, V-band ESA design for your commercial or even defense SATCOM applications, we're more than happy to support you. If our prototype inspires new ideas and you'd like to give it a shot, you know where to find us. TMYTEK always loves to help you to build your own novel concepts.